Hi guys, today we're going to learn how to find and use experimental probability. Experimental probability is when you find the probability of an event based on actual data from an experiment. To find the probability of an event, we're going to take the number of times that the event occurs and divide that by the total number of trials. Let's take a look at an example. In our first example, Jeremy is greeting customers at a music store. Of the first 25 people he sees enter the store, there are 16 wearing jackets and 9 are not. What is the experimental probability that the next person to enter the store will be wearing a jacket? Again, to find this experimental probability, we're going to take the number of times that the event occurs and divide that by the total number of trials. In this case, the event that we're looking for is the probability that a person will be wearing a jacket. So we're looking for P of a person wearing a jacket. And that's going to be equal to the number of times that the event occurs. 16 people were wearing a jacket, so the 16 will go in the numerator. And there were a total of 25 people who entered the store, so that's the total number of trials. And we can write this either as a fraction, a decimal, or a percent. If we write this as a decimal, this would be about 0.64 or 64%. Okay, let's take a look at another example. In the second example, a toy company finds that the experimental probability of manufacturing a defective doll is 3 out of 50. About how many defective dolls are likely to be in a batch of 1,800 dolls? Well, when we look at this experimental probability, they give that to us. And this 3 out of 50 means that out of 50 dolls that are produced, 3 of them are defective. So we can use this experimental probability to be able to predict how many dolls will be defective out of a batch of 1,800. So if we've got 3 out of 50 are defective, we want to know how many will be defective out of 1,800. And we can use a proportion to be able to solve for this problem. So once the proportion is set up, we can just cross multiply, and on one side we're going to get 50x, and on the other side we're going to get 3 times 1,800. And if we multiply 3 times 1,800, that will give us 5,400 is equal to 50x. And then finally, we're going to divide both sides by 50. These 50s will cancel out, and it will turn out that x is about 108 dolls. So this means that out of 1,800 dolls, we would expect, based on this experimental probability, we would expect that about 108 of those dolls would be defective. Notice that we actually use an approximation sign for that because it's not saying that this will be exactly 108 dolls, but based on what happened in the experiment, we would expect approximately 108 dolls to be defective. Let's take a look at example 3. Natalie flips a fair coin 100 times. Which of the following best describes the expected number of times the coin would land with tails facing up? Well, our answer choices are exactly 2 times, exactly 50 times, approximately 2 times, or approximately 50 times. Well, when we're doing an actual experiment, based on what we think should happen in theory, there's no promise that we would get exactly some amount. So we can go ahead and automatically eliminate answer choices A and B because it's impossible to be able to tell whether or not we're going to land exactly 2 times or exactly 50 times, but we can get a good approximation using the information from the problem. So before we learned about theoretical probability, and if we're finding what should happen in theory when flipping a fair coin, it turns out that there's 1 out of 2 chances that the coin should land on tails. So if there's a probability of 1 out of 2 or 50%, we want to know how many times out of 100 would we expect for the coin to land on tails. And again, what we're doing here is we are linking the theoretical probability of 1/2 to the experimental probability of flipping the coins 100 times. So we're going to use this proportion to solve for the unknown amount. So we'll cross multiply. So on one side we'll get 2x, on the other side we'll get 100, and then divide both sides by 2, and that unknown amount is going to be 50. So this means that if we tossed a fair coin 100 times, we would expect for the coin to land on tails approximately 50 times. So the correct answer choice would be D. Okay, so hope that was helpful. If you have any questions, please let me know. Thank you.